In this video, we're going to be looking at the hyperbola. So looking at how to graph it, how different transformations change its shape and its equation, and the easy ways and the important things to note when graphing it. So firstly, the hyperbola. What is it? So it has the equation of y is equal to 1 over x. So that's today. Its power form, its basic form. Once you can add some transformations that may change. However, it is 1 over x to the power of 1, and then you can obviously have like plus or minus c to translate up or down, which we'll talk about later. But what does y equals 1 over x look like? So firstly, let's think about what happens when x is equal to 10. Well, then y is equal to 1 on 10, so 0.1. What happens when x is equal to 100? Well, y is equal to 1 over 100, which is equal to 0.01. So you can see that when x approaches infinity, y approaches 0. So that means when x is going along, y is getting closer and closer to 0. Then what happens when x is equal to 0.1? So if x is equal to 0.1, then y is equal to 1 over 1 on 10, which is equal to 10. So 1 over a fraction brings that fraction up, and we get 10. And then when x is equal to 0.01, or 1 on 100, then y is equal to 100. So we can see that when x approaches 0, y approaches infinity. So to graph that part, we can show that by going that it comes up the top here. So when x is getting closer and closer to 0, y is approaching infinity. And then it comes down, and it goes closer to 0 when x goes to infinity. And we can graph one point on here, such as 1, 1, and then we can see that relationship. What happens when x is negative then? So when x is negative, we find that it's the same, it's going to be a similar shape. However, instead of y going to infinity, it's now going to go to negative infinity, and it's still going to approach 0, but it's going to approach 0 from the lower hand. So what I mean by that is that if we have x is equal to negative 10, then y will equal 1 over negative 10. X is equal to negative 100, y will equal negative 1 on 100. So it's getting closer to 0. However, it's going to approach it from the negative side. So it's going to go like that. Then when x is equal to negative 0.1, we're going to have y is equal to negative 10, and then etc. So when x approaches 0, then but from the negative side, then y will approach negative infinity. So we're going to have that and that. And that's a tip for drawing as well. What I normally do is I draw the end arrows like this, because the arrows can't cross the axes. So I draw these arrows in, and then draw it like that. And the important thing when drawing this is to show that it approaches infinity. So it approaches the asymptotes, which I'll talk about in a sec. So as I've shown here, there's y is approaching different values, and y is approaching 0, and then it's approaching infinity, and we have to show that. So to show that the graph is approaching x is equal to 0, we draw in something called the asymptote. So the asymptote is a value that the graph is approaching. So we draw that in by using a dotted line. And then we have to draw the equation for that, and we say that so for this one, y is equal to 0. So that is the asymptote. And then we have to also show the other asymptote. So that is when x is equal to 0, because y approaches infinity and negative infinity, but never touches the graph. So then we draw that in here. And I'd say, yeah, draw that in as a dotted line. And you can say that here, x is now equal to 0. And obviously I've done it in a thicker line just to emphasize it. However, you don't obviously have to do that. So that's what a general hyperbola looks like. So what happens when we dilate it? So if we have this general shape of a hyperbola, and then we dilate it. So there's two sort of options. It may go down like that, or it could go more like this. And then conversely, it still has to affect both sides. So if we replace y with y on a, then that means we're dilating by a factor of a from the x-axis. So we have y is equal to 1 on x, y on a is equal to 1 on x, therefore y is equal to a on x. And then if we took a point here such as 1, 1, then the new point up here, if a is equal to, let's say, 3, would be 1 on 3. So we can see that here has a dilation of a is equal to 3, here is a is equal to 1, and then a is equal to a half. Then that means this one would also have a is equal to a half, a is equal to 1, the red one, and then a is equal to 3. So you can see how the dilation affects a hyperbola. You have a reflection. So drawing the general shape. So there are two types of reflections. Firstly, a reflection in the x-axis, and then a reflection in the y-axis. So we'll say reflection in the x-axis. So that means we have to replace y with negative y. So if we do that, we have negative y is equal to 1 on x. Therefore, y is equal to negative 1 on x. And if we reflect in the x-axis, we're going to get something that looks like that. So it's basically the opposite quadrants. And you can see that by looking at the equation, it's negative. So whenever y is positive, it's now going to become negative. So what about if we reflect in the x-axis now? So we'll just get rid of this. So we'll say we are reflecting in the x-axis. Reflect in y-axis. But that was the x-axis, so we're reflecting the y-axis now. But we're replacing x with negative x. So we get y is equal to 1 on negative x. So y is equal to negative 1 on x. And we see it's actually the same equation. So here is the same reflection. So reflecting in the x-axis will give you the same result as reflecting in the y-axis. And it also means if you're reflecting both axes, then you're actually going to get the original graph. Because if you're reflecting one, then you reflect again in the other. It's like you're doing the same thing twice and they cancel out. So there are some graphs, and it depends on which, that if you're reflecting the x and you're reflecting the y, they're the same. It's going to have the same effect and the same equation. Just a quick note there that the arrow does cross the axis, and you don't want to do that. So if you do that, draw a graph in pencil, rub that end bit out, and just make sure that it looks like it approaches the axis and it doesn't cross the axis. Even if you don't have to draw the arrows, I like drawing them. However, if you do draw the arrows, make sure they don't cross. So finally, translations. So we have the general shape of the graph here, and now we need to translate it. So you know what the general shape looks like. So I'm going to give an equation here. So if we translate it 2 units to the right. So we're replacing x with x negative 2. That means we're going to get y is equal to 1 on x minus 2. As it was 1 on x, and now we've replaced that with x minus 2. Then we can think about, well, what's going to happen? The first thing to do is asymptote. So at x equals 2, it's undefined. However, when x is equal to 2.001, then y is going to equal 1 on 0.001. So y is going to be like a big number, so that's probably going to be about 1,000. And then, but the point is that y is going to approach infinity when x gets to very close to 2. So we can see that at x equals 2, that's going to be an asymptote. So x is equal to 2. So if you have y, 1 on x minus 2, then what happens when x goes to infinity? Well, y is going to approach 0. So we can see that. So then we know that the horizontal asymptote has not changed. So we can draw that in there. And we can say that this is when y is equal to 0 and x is equal to 2. And we know that graph is going to look like this. And so assume that we think the graph is going to look like that. We can check that because if that is the case, then it's going to have a y-intercept. So we can check that out. We can say that x is equal to 0, therefore y is equal to 1 on negative 2. So there is a x-intercept. So we can say that here there is 0, negative a half, and then there shouldn't be an x-intercept. So we can check that out. If y is equal to 0, then there is no way that this can equal 0. So we are correct in saying that the shape will look like this. So that's the translation in the x-axis. So then a translation in the y-axis. So a translation in the y-axis means we have to replace y with a different value. So here is an equation up above, and this has a translation both the x and the y. So to see the translation in the y-axis, we plus the 4 over, and we get y plus 4 is equal to 1 on x plus 3. So we've seen that y is replaced by y plus 4, and x is replaced by x plus 3. So we know that the graph has been translated down 4 units and translated to the left 3 units as well. And because of that, the asymptotes have also changed. And we can see in the previous example I've shown that the asymptote now is going to be at negative 3, and that is due to the value when it's negative 3 it's not defined, however when it's close it approaches infinity. So we can draw that graph in. So x is equal to negative 3. And then when x, how do we know that y is equal to negative 4 is an asymptote? Well, when x goes to infinity, then this term here approaches 0. Now y doesn't approach 0 because of this negative 4, but this term still approaches 0. So when this term approaches 0, y now approaches negative 4. And you can say that when that equals 0, then y will equal negative 4. So we can sub that value, put that asymptote in there, and we have that y is equal to negative 4. Now the shape still remains the same, as there hasn't been any reflections. However, we can check that by looking, and we see if we suppose that the graph looks like that and then that, then there's going to be an x and y intercept. So when x is equal to 0, y is equal to 1 on 3 minus 4, so negative 11 on 3. And then when y is equal to 0, we're going to have 4x minus 3 is equal to 1. So 4x minus 12, and then that's a plus, sorry. So it's going to be plus 12, so minus 11. Therefore, x will equal negative 11 on 4. So we have negative 11 on 4, negative 11 on 3, and so that looks about right. So we can draw the graph in, and then obviously you want more room, but the graph will also be the same on the lower axis as well. So that is y is equal to 1 on x plus 3 minus 4. You want to show what these points are. So that point says 0, negative 11 on 3. and then negative 11 on 4, 0. So you have to show the equation of the asymptotes and show the x and y intercepts, just like any other graph.